First, let us define what is flotation. Flotation is any operation that involves one solid being separated from another by floating one of them at or on the surface of a fluid. So, it is a separation process. It is based on the use of very fine gas bubbles that attach themselves to the solid particles. So, having said this, the process depends upon the successful application of a number of physical principles, and these are the following: film suspension, oil buoyancy, and bubble levitation. Film suspension is caused by surface tension, and surface tension is the force that causes the surface of a liquid to resist rupture. This, in turn, is due to the fact that the molecules at the surface have a greater coherence than the molecules within the body of the liquid. In consequence, the surface acts as if it were an elastic film. Next, we have the oil buoyancy. Oil buoyancy is a simple manifestation of gravity, whereby an oil, being lighter than water, will rise to the surface of a pulp and carry with it any mineral particle that have become immersed in it. So that is oil buoyancy. Next, we have bubble levitation. Bubble levitation depends upon the aid of the bubbles of gas by attaching themselves to particles of mineral buoy them to the surface. So again, flotation process depends upon the successful application of these physical principles, namely film suspension, oil buoyancy, and bubble levitation.
In the diagram, the two basic steps in flotation are shown. These are conditioning and separation. The feed, which is a slurry or mixture of particles with proper size and density, enters the conditioning unit. The flotation reagents are fed continuously. After sufficient time of contact, physical-chemical conditions are then created to achieve a proper selectivity between particles to be separated. The second step, which is separation, involves the introduction and generation of bubbles. The particles attach to the air bubbles and are then recovered as froth. Flotation process typically makes use of 6 units or equipments. First is the ball mill or crusher. Particles larger than mesh 20 are crushed to desired particle size, which ranges from mesh 200 to mesh 20. If particle is too big, the air bubbles would not be able to support the solid in the froth. Next are vibrating screens or classifiers. Particle sizes are controlled prior to conditioning. The third unit is the conditioner. Solid to be floated is coated with filming reagents for selective separation. Rougher is the first flotation cell where the initial or rough separation is done. Scavenger. It is the unit wherein desired material is further removed from the undesired material or tailings. Cleaner or finisher. This unit further frees the concentrate from the tailings. It must be noted that the first 3 operations are strictly not considered as flotation cells, but they are needed for pre-treatment of the feed before flotation process. The flotation process can be best understood using a diagram. This diagram shows the separation by flotation using rougher, scavenger, and cleaner cells. After allowing sufficient time for the solid to be filmed or surrounded completely by the reagents, the overflow from the conditioner enters the rougher. In the rougher, the first or rough separation by flotation is made. The floated material is termed as concentrate as it contains the desired mineral. The particles that sink and remain in the water are removed from the bottom and are called tailings. The removed tailings from the rougher may still contain some of the desired minerals, so they are fed to the next flotation cell, which is the scavenger. The floated product from the scavenger is returned or cycled to the rougher with a feed. The tailings from the scavenger are the final tailings. The product floated from the rougher may contain more gangue than is desired. This may be reduced by feeding the overflow from the rougher to a third flotation cell called the cleaner, so operated as to give the desired quality in the concentrate. Under these conditions, the tailings from the cleaner contain material desired in the concentrate and are cycled with a feed to the first cell or rougher. Flotation reagents. The reagents used in flotation can be classified as collectors, modifiers, and frothers. Collectors. These are a fairly large group of organic chemical compounds. Their basic purpose is to selectively form a hydrophobic layer on a given mineral surface in the flotation pulp and thus provide conditions for attachment of the hydrophobic particles to air bubbles and recovery of such particles in the froth product. Frothers. These are heteropolar surface active compounds that lower the surface tension of water and have the ability to adsorb on the air bubble water surface. Their presence in the liquid phase increases the film strength of the air bubbles, thus providing better attachment of hydrophobic particles to bubbles. Modifiers. These are reagents used to modify the action of the collector on mineral surfaces and as a consequence govern the selectivity of the flotation process. These can be classified as activators, depressants, pH regulators, and dispersants and flocculants. Activators are used to make a mineral surface amenable to collector coating. An example is copper ion used to activate sphalerite. pH regulators. As the name implies, these control or adjust the pH, which is a very critical factor in flotation processes. Examples of these are lime, caustic soda, soda ash, and sulfuric acid. Dispersants and flocculants. These two are important reagents for controlling slimes which sometimes interfere with the selectivity. Consequently, these control increased reagent consumption.